This is the EEGR 211 report on lab number 4 on registers and counters. My name is Sadi Williams.
My name is Michael Bush.
And as you can see right here, for the process in designing the gray code counter, which was first thing we had to do, here's the transition graph, the tables, and the K-maps that we use. See the equations down there.
Here's the physical representation of the circuit at the bottom. We have them both connected, so they're both going at the same time, so we won't have to switch wires out. But yeah, this is your gray code counter down here. As you see it stepping through, this would be your most significant bit, and this would be your least significant bit here.
Right.
And you see it's 1 0, 1 1, 0 1. So.
And as you see over here, this is the simulations, the circuit simulations for both the gray code counter and the shift register. We're going to start with the gray code first. And as we run the simulations, it starts at 0 0. Bear in mind that the rightmost flip-flop here with the rightmost LED is the most significant bit. So it starts at 0 0, 0 1, 1 1, and then 1 0. And it goes right back to 0 0, and it just repeats. And this is for the shift register. And this is the leftmost one here is the most significant bit. And much like the previous one, we're going to start at 0 0 0. So this is 0 0 0. This is 1 0 0. This is 1 1 0. This is 1 1 1. This is 0 1 1. 0 0 1. And then back to 0 0 0. And it repeats. You see 1 1 0 0 again. So as you can see from both the simulations and the physical circuit that they do match up. And
this is the shift register here. Our most significant bit would be green. Our least significant bit would be red. And blue is your middle number. And as you see, it's stepping through.
Yep. And as of right now, we do have it set at 1 hertz.
1 hertz. Your bias would be 5 volts. And if you do increase your hertz, see if you want 5 hertz, as you see, it's going very, very fast stepping through. I recommend to set it at 1, so you can have a slow enough pace, so you can see everything going as it is. If you leave it at 1K, you're just going to see that it's going to be basically not moving at all.
Yeah.
As you see, we got 100 hertz. It's going bananas.
Yep.
So
that's why when doing this project, we do recommend that you do it at a low frequency.
Do it at 1 hertz. If you go any higher than that, it's going to be kind of hard to keep up.
Indeed. Problems that we may have ran into was just implementing the switch for both circuits, because the idea of the project was to implement a switch where if the value U equals 1, the value U equals 0, the transitions will be different. But because we kept on getting errors, but we did find a way to make the simulations run properly and get the right values without the U for both the gray code counter and the shift register.
And this is when U is equal to 1.
Yep.
When you have U equal to 1, you're supposed to have 1 0. I think that's what it was.
Yeah.
Yeah, you're supposed to have 1 0. And as you see, we have 1 0. So then when you move U back, in place, as you see, it starts over again.
Yep.
Yeah.
So after that, you see any problems?
I mean, other than that, man, make sure you have your clocks connected. Make sure you use the right bias voltage. You don't want to fry any chips like we did.
All right. And that's
Pretty
it.
much it. Thank you.
Thank you for listening.